All right. And then, sorry about all this. Welcome to the workshop this morning. Karla is the first speaker. We are going to have, I guess, a morning section here. Probably we're going to stay a little bit longer because we started late. So without further delay, I think you, Karla, you should start your presentation. And thank you so much for waiting, Karla. We're so sorry.
Sure. Can you make me host on Zoom so I can share my screen? Because I right now I cannot share my screen.
You cannot share. Karla, allow record. Huh? Make host. Yes. All right.
Perfect. Thank you.
All right.
Can you see my screen now?
Yeah.
Yeah. Good. We're good
Yeah.
to go.
Yeah.
Perfect. So good morning, everyone. We're ready to start. I hope you can hear me well now. My name is Karla Garcia, and I'm going to speak about vertical farming system and control environment agriculture, mostly focused on vertical farming in this time. And just a little introduction about myself. I'm technical service for Hort Americas and also consultant. I have a microgreens farm and a vertical farm in a plant factory. And I am the short course instructor for Hort Americas. And Hort Americas is a company that provides solution for greenhouse management and also plant factories. So we have lightings, fertilizers, and sensors, everything that is useful for greenhouse management and also vertical farms under artificial lighting. So let's start with a quick introduction about why CEA is important and all the technologies and the development around this is important. So we need to know how to use the advantages of control environment now so we can make good business. However, we know that the impact of all these tools that are being developed are very important for food safety. We want to be able to produce food in a more sustainable way, and this is something that we require. I mean, this is something that we really need. However, for now, we also want to have good businesses, and this is actually a very, very good reason of starting control environment system, meaning a greenhouse. So the success of today can be a tool that we can use tomorrow to overcome difficulties on food safety. So the importance of controlled environment agriculture, we are able to farm more in less space and to have bigger business for small growers. So by having greenhouses, we are able to produce food and have business in different places. We can allow us to produce more in less space, and that's something where vertical farming is also obviously taking in consideration. One of the most important aspects of controlled environment agriculture is that we are not in open field. We are not expenses of the environment outside. So we are able to control it, obviously depending on the environment and the technology. We're able to control temperature, humidity, lighting, and that increase the production window that obviously is good for business. We can reach better prices at the market, and we can get annual contracts. Also, if we're able to produce food in our own cities, we can generate local jobs, and this is something that is really valuable for the people in the city. Usually, people is demanding more locally grown produce. There are a lot of surveys where people usually share these necessities or this interest in having more fresh product that is not like transported in long distances. Pesticide free, and also the nutrient content is something that is important now. Other advantages is the local job, reduction in shipping, and of course, this also is important for the environment. There's a lot of pollution because of the transport of food in all the world. And also the food quality can be improved. There are different ways to do indoor farming. Actually, greenhouse production is part of indoor farming. It's a very different system where we have natural light, and the rest is usually called a plant factory. So a plant factory is a system where we don't have natural light and we just have artificial lighting. We are going to discuss a little bit about the differences. Both systems are great and it can allow you to produce in a bigger window of production, but it depends, of course, on the type of business that you want to get involved. So I was mentioning that control environmental agriculture is important also for food safety, and this is because we know that the population worldwide is increasing, and that of course is demanding more food, demanding more use of resources, and that is not good. I mean, we know that we don't have enough resources to keep producing food at the same way as we are doing right now. So we need to start to develop new technologies and new systems and improve the systems that we already have so we can be able to produce more food. We need to produce actually 90% more food by increasing only 10% of the land use. And this is mentioned by the FAO. So this is something important, and that's why there's a lot of research around controlled environment agriculture involving greenhouse technologies and also vertical farming technologies. So here we have two different companies, vertical farming companies. On the left side, we have Plenty, and on the right side, we have Aerofarms. These are very big companies, vertical farms, and as a consultant, I always like to mention that we don't have to start this big in order to have a business like this. I'm a microgreens grower. I have a small facility, and it's a profitable business that I started when I graduated from grad school. So there are different ways to start, and a vertical farm is a good way to start a small business too. It doesn't have to be something like this. Actually, it's better if you start small and then scale up. That's why actually some of the business on the past have been not successful, and this is because of like huge investment without taking in consideration that this is a like new business. And that is why you can read, or the news sometimes will say bad aspects about vertical farm business, but it depends on how you approach this business. It's better to start small and then to grow once you have you already have the results and you already are successful in the small business. So let's define what is a plant factory. So a plant factory is a system with the control of different variables, starting with light. We are also controlling temperature, humidity. Depending on the level of technology, we're going to be able to control also CO2 or the gas exchange, for example. What is the main difference between a greenhouse and a plant factory? Both systems are great. The advantages of a plant factory would be that in a greenhouse, we have natural light. That means also natural radiation, which means heat, that sometimes can be something that is not beneficial in a specific windows of production when you are having like high temperature and you are using a cooling system. Sometimes it could be more expensive when you have natural light in the terms of trying to cool down the system and to make a profitable business in a greenhouse. So it will depend obviously on the type of project. Also, in a greenhouse, we have a little bit more incidence of pests. Plant factory is a little bit more enclosed environment, so we can avoid pests a little bit more easy. I mean, we can have pests too, but it's a more enclosed system that we can control a little bit better. And of course, we can control better temperature, humidity. It could be more constant, and that is good for the results. I mean, we can have more predictable results and consistency in our production. Another advantages of vertical farming systems is that we could be placed in like anywhere. Usually it's designed for to be inside of the cities, buildings that are already there. So we don't have to use natural land, for example. That is what we usually do for farming. This kind of system can help us to produce year-round production, to have better quality. We can have like pesticide-free production. It's an option. I mean, it could be, and it's easier than doing this in a greenhouse. We will have less bacteria, so that will increase the shelf life of the product. And of course, if we are inside of the cities, we can reduce the transport and we can reduce pollution. So as I mentioned, if we are able to control variables better, we can have more consistency and more predictable results. That's good for all growers. And depending, of course, on the management of variables, it will be a very consistent result. So for example, in here, we have light and the days to harvest. And you can see in here how by increasing light, you are reducing the days to harvest. And in a plant factory, you can like really control the amount of light that the plants are receiving. A little bit different from a greenhouse where you can have like cloudy days, sunny days, and sometimes also depending on the season, you can have different lighting inside of the system. Here is a little bit more predictable. So which are the components for a plant factory? It will depend on the type of plant factory that you're working with. I don't want to say that it's mandatory to have everything that is in here. It will depend, but most of the time we have a thermally well insulated room. We want to have a room that we can control better temperature inside. Just think about having a room, for example, with very thin walls, and outside is very hot and you have an AC unit inside. Of course, it will be more challenging to try to reach the temperature that you want. It will be more expensive. So we want to have an insulated room so you can be able to control the variables better and to reduce your operational expenses. Inside of a plant factory, we can have multiple layers to have a system that is called vertical farm. We can also have a plant factory with no vertical farms. I mean, just one layer of production, which is very common for cannabis, for example. But for vertical farms, usually we want to work with 4 layers or more. We also have in the system, inside of the system, we have an AC unit. We have also a unit that can produce heat in case is required. We can also have a CO2 generator. We need to have fans for ventilation, and of course, we need to have lamps. Depending on the plant factory level of technology, sometimes the CO2 unit, for example, is not required, because we can do gas exchange to try to get in CO2 from outside. So there are different ways to do it. But if it's more control, of course, you will have a CO2 delivery unit. Inside of plant factories, we usually have hydroponic systems. So we have a nutrient solution. We have a system that will provide irrigation. So we will learn a little bit about that too. And of course, you need to monitor the system. You need to have sensors in order to measure all the environmental variables, including the ones from the hydroponic system, like pH or electrical conductivity. So some of the objectives of a vertical farm are to maximize the amount of production inside of a system. So that's very important for the design too. If you already have the area that you want to work with, let's try to work on trying to pull out from there as much production as possible. We also want to be careful on the selection of the different systems that are inside. Like, for example, the lighting system, the irrigation system. We need to think about how to select our capital expenses, which are the expenses that we do at the beginning, in order to reduce the operational expenses. So the operational expenses are the expenses that you have like every month. You need to pay for power, you need to pay for water, for gas. So be careful with the lamps that you're selecting. There are lamps that can be a little bit more expensive, for example, but better quality and more efficiency, and that will reduce your operational expenses. So sometimes it's better if you invest a little bit more at the beginning so you can reduce your operational expenses, which are expenses that you will have all the time. So that's very important in the design of the system to try to minimize the cost of operational expenses, obviously without sacrificing nothing that will affect quality or the yield. So we already know a lot about vertical farms for leafy greens, for example. Now the research that is going on around vertical farm is very focused on efficiency. We know already how to use lights for some crops. There are other crops that are under research. However, now we want to learn how to be more efficient, and this is involving light. So now we have different brands, and all the brands are competing, trying to make lighting fixtures that are more efficient. And the way to measure this is by checking the efficacy of the lamp. Usually this should be more than 3 micromoles per joule. And we also need to think about all the resources that we're using, like water, gas, everything that is involved in the production, so we can make our system more efficient. And that will also include how we design the system so it can be operated by someone. If you can reduce, for example, the labor, that's also something important. So here we have the resources or plant system, and we also have the final result, which are our plants, or production, and the value that involves also the use of vertical farming systems. So a plant factory can be a little bit complicated. I mean, there are a lot of different variables involved. There are very good books like the one called Plant Factory by Dr. Gosai. And in that book, the author mentioned a lot of different equations and very, very useful information. So today I want to summarize that information so you can learn in an easy way all the environmental variables, I mean, the key information, and how is the management inside of a plant factory. I mean, there are some differences in comparison to a greenhouse. So let's start with the lighting, which usually is one of the most new topics. I mean, when we work in a greenhouse, we work with natural light. So now we're going to learn a little bit about how to measure light and how the colors of light can affect plant growth. So to measure light, we use a unit that is called ppf. So that is photosynthetic photon flux. So this unit is it's micromoles per square meter per second. It's an instantaneous measurement that involves the spectrum from 400 to 700 nanometers. So that is the amount of light that the plant is using for photosynthesis. And this is the only unit that will take in consideration that range. If you work with watts per square meter or luxes, it's a little bit different because those units are made based on how we see, I mean, how we humans see. And in this unit, it's based on how the plant is using light. So this will be the correct unit to be used. You can convert from luxes to ppf, for example. And again, this is an instantaneous measurement. So this is a measurement that you will get in a second. I mean, if you have the sensor, you put the sensor below the lights and you will get the ppf. Another important unit for lighting is DLI. So DLI is the amount of light per day. So meaning ppf accumulated per day. So the unit is mole per square meter per day. And we already have information about the DLI requirements for a lot of different crops. So for lettuce, microgreens, strawberry, sweet pepper, cucumber, tomato and cannabis are very similar. So we have plants that they love light, like for example, tomato, cannabis, they can be under 30 DLI and even more. We have plants that are very sensitive to light, like for example, strawberry is very sensitive to light. And lettuce is like a middle on the middle. And microgreens is one of the crops that requires less light. So in case you are like looking for a business where not a lot of light is required, microgreens can be also a good option. So it's very important to be able to look for this information. If you're working inside of a plant factory, you need to know the requirements of light for your crops. And also for greenhouse management. Usually this will allow you to select shade cloths or the use of supplemental lighting in case it is necessary. So if we speak about light quantity, then we speak about ppf, which is the amount of light that the plant is receiving. And we can also speak about light quality. When we speak about light quality, we're speaking about the colors. So this is just an example so you can get an idea of the light quantity that we have outside. This is Tucson, Arizona. It's a city with a lot of light. This is a desert. So we have on the x-axis the days of the year. On the y-axis, we have the DLI. So you can see in here how the DLI is moving from 30 to almost 70. If we take the average, which is the green line, I mean, where we have the most spots in here. So this is just to let you know, I mean, we have a lot of light outside. There are some products that can be used in order to reduce the light, so the plants can be less stressed. There are some crops that love light, like for example, cannabis or tomato, but they don't like high temperatures. So that's why we use shade cloths. That's why we use this kind of products that can allow us to reduce the light intensity inside of the greenhouse. And if we speak about the colors, as I mentioned, the plants, they do photosynthesis from 400 to 700 nanometers. This is called PAR. This is the photosynthetic active radiation range. In here, we have different colors. We have UV lighting in here below 400, and we have far red after 700. So those colors are outside of PAR. But they are also related to plant growth. I mean, there is a lot of research now going on in those areas. However, the most important colors are in PAR. So we have red, we have blue, and in here we can see these lines, which are this is the absorption of chlorophyll. So you can see in here, this is chlorophyll A and chlorophyll B. And you can see in here that in red and blue, we have more absorption. We have peaks of absorption, meaning that the plant is using more red and blue light for photosynthesis. And that is why lamps usually have red and blue. So these are the most important colors for photosynthesis. And the rest of the colors are also important. They could be involved in flavor, texture, or other aspects. So usually for the lighting, we always select a lamp that will have red. Red is always in the highest percentage. Then blue, low percentage, and we can have a little bit of green, which is usually the white LED. And this will be like a safe area, I mean, safe color that will involve all the colors. White light involves all the colors. So in case a color can be useful for flavor, texture, or something else. However, always red and blue will be the colors in the highest quantities. So how plant lighting is going to impact photosynthesis and also the quality of the products. As I mentioned, outside of PAR, we have far red, and there is a lot of research now around far red. We know it's helpful for flowering. We know it's helpful for stretching, for shading avoidance response, and also for antioxidant content. So for leafy greens, for example, we know that can improve the light capture. We don't want a lot of far red because it will stretch a lot of the plants and they will be deformed. Same case for red. Red is the most important color. However, you will never find a lamp that is all red. It will have just red. We will have a stretch on the plants, and that's not good. But we want red to be the color in the highest percentage because this is the color that is more involved with the energy on our plants. Then we have green light. Green light is useful for plants. It's not as useful as red or blue, but we want to have green usually as a safe color in a case the plant requires also this color for different plant processes. And blue light is important for photosynthesis. We know it's important for root development and also for promoting compactness in plants. We don't want to have just blue light because the plants will be very compacted. But if you are working, for example, let's say transplants, for transplants, we know that compactness is a good quality, a good characteristic. So if you have more blue, you will be able to have a stronger transplant. So usually for transplant, we want to have a lamp with red. Red, again, is always in highest quantity, but we want to have more blue than for other crops or other situations. UV lighting is useful for plant factories. Is under research right now because it's not very efficient. As I mentioned, we are working a lot around efficiency right now. And efficiency will be all the colors inside of PAR, that they are directly related to photosynthesis. So right now there is research done about UV lighting. We know UV lighting is useful inside of the greenhouse. There is natural UV lighting that will help you, for example, to improve the color of lettuce, of the red lettuce. But for example, inside of a plant factory, we know that we can also use blue and far red to increase the coloration. So depending on the purpose will be the type of light that you are using, but you need always to think, I mean, if this is a business, you need to think about selecting a lamp that will make also your system efficient. So usually what is outside of PAR will make your lamp fixture less efficient. That means far red and UV light. So for example, in here, we have some results from Eric Runkle. And you can see in here how the light quality can affect the quality of the product. So you can see in here, for example, lettuce. If we don't have, for example, if we don't have blue, if we have just red, you can see a lot of stretch. So this is red and far red, and we have the form plant. Here we have just red and blue, and we have a lot of blue, so the plant is more compacted. And if we mix colors like blue, red, and green, which is the white LED usually, we can have a more normal shape. And for example, if you're working with red lettuce, we know that blue can help with coloration. We know that far red can also help with coloration. And we know that if we don't have far red or we don't have blue, we will stay with a green lettuce. So that's very important if you're working in a plant factory and red lettuce. You need to include a color that can help you with the coloration of the plant. So here you can see this is red lettuce, and this is just using red, using white, so white in both all the colors, and using blue light. Light intensity is also important. The plant can get stressed when it has too much light. In plant factories, actually, the plant is more sensible because of the environment that is surrounding the plant. So, for example, in a greenhouse, we can have more light intensity. We already, we'll look at the graph of the DLI. Natural DLI is huge inside of a greenhouse, and we can have normal growth for lettuce. However, if we take the same light intensity to a plant factory where the environment is different, so the movement of calcium, for example, is different because of the transpiration inside, it's easier to get tip burn, which is calcium deficiency, by having a very high intensity. So in here you can see if we have more than 300 ppf, we start to see some problems with the quality of the product. So we usually want to target to have a DLI of 17 for lettuce inside of a plant factory. So this is also the response of plants with supplemental lighting inside of a greenhouse. We know there are a lot of places where the natural light is not enough, so supplemental lighting can help to improve yield and improve the quality. For other crops, like for example, for strawberry, there's a lot of research going on right now. the most important aspects right now to share is that strawberry is very sensitive to light, and this is actually the same for open fields. So we have plants stressed outside usually. So we know that the light intensity should be around 200 to 150, and I mean, if we go above that, we can damage a little bit the photosynthesis process on the plant. I did my research in the strawberry when I was in grad school, and actually my research was about how light is impacting photosynthesis in strawberry. So we know when you have too much light, even inside of a greenhouse, you can have a negative feedback in photosynthesis, meaning that the photosynthesis is decreasing within the day, which is not good. So that's why it's important to select the good light intensity for also strawberry. And speaking about the light quality for strawberry, we know far red is important. So far red is outside of par, and we don't want to use a light fixture that is less efficient, only if it's necessary. So for strawberry, we know right now that it's kind of necessary because of the shape. Otherwise, the plant stays very compact, and you know that strawberry tends to hang from the plant. So we want to have the peduncle, which is the portion that is attaching the fruit to the plant. We want that to be long. So for that, we know that it's better if we can have red, we can have blue, but at least 5% of far red. So this is for strawberry. So this is an example of the spectrum of a light fixture. So usually we have a peak in red, we have a small portion of blue. We can have a white LEDs, so will be this portion in here. And in here we have also 5% of far red, which is this part. So this is an example from the lights that we manage in Hort Americas, which are the Arise Life 2 lamps. So this is the lamps that we manage at Hort Americas. And as I mentioned, it's very important to have good quality. Some lights, they have a higher price, but they are more efficient, and that is better for projects. I mean, in order to reduce the operational expenses. Usually a lamp fixture for a vertical farm will be between 200 and 300 micromoles. And that's the intensity that you usually get. Good. So if you want to calculate the amount of hours that you need to turn on the light inside of a plant factory, here is a very useful formula. So you need first to check what is the DLI requirement for the crop that you're working with, and also to check the light intensity from your lamps. So in here you need to put the light intensity at the canopy level, and here you will select the DLI that you want. And after applying this formula, you will get the number of hours of light, meaning the photo period that you need to use in order to deliver a specific DLI. So this is mostly used for leafy greens, for example. For other crops like cannabis or sometimes strawberry, we know that the plant needs a specific photo period depending on the response. Cannabis, for example, is a short day plant. And some strawberry cultivars are also short day or facultative long day. So you need to, you can work with this formula, but also take in consideration if the plants require a specific photo period. Good. So now I'm going to move and speak a little bit about environmental variables inside of a plant factory. We have light, but we have also other variables, like for example, CO2. I mentioned already that it's not like necessary to have a CO2 unit inside of a plant factory, but what is necessary is to be careful and check that you have enough CO2 inside of the room. You can get CO2 from outside, for example, or you can have a CO2 unit. We know that CO2 is important for photosynthesis. If we have more CO2, we have more photosynthesis. And it's obviously into certain levels. If you have too much CO2, that can also be bad for plants. It can get stress. So it's a response that is something like this. We know that by enriching the environment with CO2, we can increase photosynthesis. We can increase also the yield from 14 to 45%, depending on the crop you're working with. Of course, there is a price for increasing the CO2 inside of the room, so you need also to take that in consideration. Plants usually require about 300 to 400 ppm of CO2, but by doing CO2 injection, you can go and reach higher levels. For example, if you have more than 1,000 ppm, for most of the crops, you will see a benefit on photosynthesis. Obviously, is a response that is depending on the crop. But we know that if you have more than 1,000, a lot of crops, they can have a benefit for that amount of CO2. If you increase CO2 just a little bit, let's say from 400 to 700, you usually don't see a benefit. So how can we make sure that we have enough CO2 inside of the room? We need to have a sensor, of course. And we can use ventilation from outside to inside, or you can use the CO2 cylinder, which is a compressed CO2. And in a greenhouse, we usually use propane combustion, but in plant factories, we usually rely on these cylinders with CO2. There are other environmental variables. All environmental variables are related to a specific response in plants. For example, temperature, we know that it can help with development and also the translocation of sugar. Wind is very important to optimize the process of photosynthesis and nutrient uptake. Light, obviously, is related to photosynthesis, which is growth. Humidity is related to plant health and nutrient uptake. The nutrient content, of course, is related to crop performance. And the CO2 is related to photosynthesis. So let's speak about each of the variables, and I will try to summarize the key information that is more important for a plant factory. So temperature inside of a plant factory is usually more controlled. So it's weird to have a stress because it's too warm or it's too cold. Usually we have tools in order to prevent that. But it's good to know that if we increase temperature a little bit or decrease the temperature a little bit, you will have a response. And the response is mostly to the metabolic process in the plant. Usually, if you have higher temperature, the plant will start to develop a little bit more quickly, and that can sacrifice quality. And if we have less temperature that is required, let's say just some degrees, of course, this is not like stress, but if the temperature is a little bit lower, you can have a plant that is more slow. Usually the metabolism gets slower. And let's say, for example, the days to harvest can extend a little bit. When we work with plants, we separate day temperature from night temperature. This is because day temperature is more related to photosynthesis and how the plant is working. And night temperature is more related to the process of respiration. So usually at night, we want to keep the plants a little bit slower. We want the metabolism to be slower. So the plant is not using a lot of energy for the process of respiration. That's why usually night temperature is lower than day temperature. And usually the night temperature is not the temperature that is required by the crop, but it's the temperature that we want in order to prevent this waste of energy at night. If the temperature increases a little bit, I already mentioned that if we have a higher temperature, we will have a faster metabolism. And I mentioned already that will involve sacrificing a little bit the quality. So for example, if you have higher temperature, the plant will make more flowers, let's say, but those flowers will be smaller because the plant has the same energy, it's only working more. So you will have smaller flowers and that will make smaller fruits too. Most important aspect about temperature, the plants respond to average daily temperature. So when you are managing temperature inside of a plant factory, you need to think about that the temperature that you read that the plants require, that is average. So you are able to change temperature within the day, but maintaining the average. That's good for operational expenses. Obviously, it will be more expensive if you try to reach one temperature the whole day. Of course, the plant will be super happy about that, but it will be expensive. So it's good to have strategies in order to know when to use the CO2, when to use the AC unit, sorry, or when to use a heater. So we want to maintain the average daily temperature. And of course, this doesn't involve extreme temperature. I mean, if it's too high or too low, that will make a response in the plant. But usually we don't see this in plant factories, as I mentioned, unless something happened. We usually don't see like a stress for very high or very low temperature. We usually have the systems in order to prevent these situations. So a greenhouse is a little bit different from a plant factory. In a greenhouse, we usually reduce temperature by evaporation. So we have wet walls, we have fogging systems, and that will help you to reduce temperature. Inside of a plant factory, we want to use an AC unit. We don't want to have a fog system. We don't have wet walls usually inside of plant factories, because that will increase humidity, and we already have plants in there that will make transpiration. So it's very common situation inside of a plant factory to get like suffocated because the plant is transpiring too much, and depending on the irrigation process that you have. So let's avoid the use of fogging systems or also wet wells. If we have too much humidity, that will cause condensation, and condensation will release heat. So it's a very common situation for growers in plant factories to have fungi, for example, or problems because it's very suffocated. Suffocated means high humidity, high temperature, and it's hard sometimes to manage. So in order to prevent this, we usually have exhaust fans inside of a plant factory, and that will help you to eliminate or replace the humid and warm air for air that is fresh and with less humidity. So that's why also ventilation is very important. Ventilation will help you also to reduce this situation of like suffocated situation inside of a greenhouse or a plant factory. And ventilation will also help you to promote nutrient uptake, to promote photosynthesis. Ventilation is not only there to make uniformity on temperature and humidity, which is something that we usually think that is important. I mean, ventilation is important because of the uniformity, yes, but it's involved in other processes. So ventilation is a very, very important process inside of a plant factory. And here is a design done by Dr. Jean at the University of Florida. She works a lot in trying to make a very uniform ventilation inside of plant factories. I will recommend you to check her articles if you want to learn more about uniformity ventilation inside of plant factories. And as I mentioned, ventilation is very important for different plant processes. It will allow you to reduce the boundary layer. So the boundary layer is a bubble of heavy air that sits on top of the leaf. When we have too much humidity, when we don't have good ventilation, that will affect how the stomata are working. So the stomata are in charge of transpiration and are in charge of taking CO2 for photosynthesis. So by having bad ventilation, we can increase the boundary layer resistance, and we can make the process a little bit difficult for the stomata to work. So that could end up causing like tip burn, for example. I mentioned already that a lot of light can cause tip burn, and bad ventilation can also cause tip burn inside of plant factories. We don't see tip burn in greenhouses because of lighting. This is a very particular situation for plant factories because of the environment. Calcium is moved by transpiration. So if it's suffocated, for example, calcium is not able to move as well as usually, and if we have too much light, the plant is growing too quickly, so calcium is not able to reach the cells on time, and then we see something like this. But most of the time, this is caused because bad ventilation. I mean, bad ventilation and light can trigger tip burn inside of plant factories. So usually we want to have a wind or an airspeed between 0.2 to 1 meters per second. Then let's speak a little bit about humidity. I know that most of you probably know how to work with relative humidity, so I wanted to put something different. So let's speak about BPD, which is a vapor pressure deficit, and is a measurement that is useful for growers. As I mentioned, inside a plant factory, it's common to have this suffocated situation. So BPD is actually the amount of vapor that we still have inside of the system before reaching the saturation point. So BPD will help you to know when you are like crossing the line between having a fresh environment. We know humidity is nice for plants, but there is a line in there that you can cross and they have fungi and high temperature. So BPD will help you to avoid to reach that situation. BPD is directly related to transpiration. And the best way to understand BPD is by comparing BPD with humidity. So usually if we have high BPD, that means that we can put more moisture in the air before reaching a saturation point. That means that our environment will have less humidity. On the other hand, if we have lower BPD, that means that our system is almost saturated by humidity, meaning that you have a lot of humidity on the system. So that is the relation between BPD and relative humidity. And you can calculate BPD by having temperature and humidity. And there are some calculators. There is one by the University of Arizona. And there is also a calculator on the Professor Greenhouse website, Dr. Greenhouse, sorry, website. So you can go there and make the calculations if interested. So the recommended levels for BPD is about 0.7 to 0.8 kilopascals, but this is crop specific. And even in a same crop, it will be depending on the development of the plant. So if you want to work with BPD, you need to go and check the requirements for the specific crop that you're working with. Good. So those are some of the environmental variables that are important for vertical farming systems. Now we're going to learn about the hydroponic systems that we use and a little bit about the design of a vertical farm. Here we have another company. This was fifth season, sorry. This used to be a company, one of the biggest companies in United States, actually in America. But they went out of business, and this is just to mention again that sometimes it will depend on how you start business, and sometimes it's better to start small. Like for example, here we have a smaller facility, and usually you can start with microgreens, baby leaves, or lettuce, which are leafy greens are usually the best option for vertical farming systems because are the crops that are more well studied in terms of business and also the management. So this is an example of a plant factory that we designed. This is in Mexico. So here you can see the final growing area. We have transplant area and we have the packaging area. So it's very important to always have these three areas. It doesn't matter the size. You can be in a container, and also let's try always to manage an area for germination, which is the transplant area, and then the final growing area and a packaging area. Usually you want to have these three areas so we can work more efficient inside of the plant factory. So this is a deep water culture system with floating rafts. This is for lettuce. So you can see here the reservoir. We want to move the water. We're going to learn about that in a minute. And here we have an ebb and flow system for germination. So it's very important to have the germination area because that will allow you to produce more. It's not the same to put a seed in this system and wait for the lettuce to be ready than to harvest a lettuce and bring a transplant that is already 2 or 3 weeks old. That will make your production faster. So we always want to have an area for germination, and also the area for packaging is important. And you can have a fridge for the storage of the product, which is usually at 4 degrees Celsius. So this is just an example of the piping that we usually use for a deep water culture system. We want to move the water from the reservoir to the multiple layers. So, which are the hydroponic systems that we usually use inside of a vertical farm? We use deep water culture system. This is actually one of the systems that is more recommended by scientists. I usually ask to everyone. I'm a consultant, so I always try to get information from the academia and try to provide that to the growers. And deep water culture seems to be a good option. It's easy to manage. It's less material, so it's cheap actually. And it's more uniform in terms of electrical conductivity, pH. So it's a good system. Then we have an NFT system, which is the tubes, the PVC tubes, and the ebb and flow system that is usually used for transplants. So the deep water culture and DFT is the same system. It's a system where we have water, we have floating rafts, and we need to build a pond. So in a greenhouse, we usually have like a pool. I mean, it's a big pond. And this is because in a greenhouse, we have natural radiation that can hit the water. So it's not necessary to have those big ponds inside of a vertical farm. So in a vertical farm, we can have something like this, which is way smaller. It's good because, I mean, this system is good because it's easy to install. You can make this with plastic or with wood. We have some systems, we have some customer that they made the ponds with wood and covered with plastic, with a polyethylene, in order to make the small ponds for each of the layers. So one of the most important aspects is power. So usually if you are recirculating water, you need to have a backup of power. In this case, for deep water culture, the water is there. So if you lose power, the water will be there and the plants will be on water. So it's not like a very critical situation. So it doesn't require back power. Of course, if it's for like 1 day, if it's too much time, you can get bacteria because we want to move the water that is in here. If the water is without movement, you can get bacteria. So this is an example of the system that is made with wood and covered with black polyethylene. And then we have there the floating rafts. And as I mentioned, it's important to move the water. We have a reservoir and we have pumps, so we can move the water from each of the layers to the reservoir. So this is just for creating oxygen. We want oxygen on the root zone. It's important for plants. Otherwise, you can get bacteria, anoxic bacteria that can develop because of the lack of oxygen on the system. So usually we want at least to move all the volume of water every 2 hours. That usually gets you the ppm that you require for oxygen, which is between 4 and 7 ppm for lettuce. This is an example of a design that we made. And inside of the floating rafts, you will get your plants. This is an example of the density that we use for lettuce and the density that we use for basil. Remember, this is the final growing area. You need to have another area with higher density for the transplants. Another system is the NFT system. So this is a system with channels. We have a reservoir and we need to recirculate the water all the time. So you need back power for this one. It's a good system because it's lighter than the deep water culture system. It have more material, more accessories. So it's a little bit more expensive. But it could be a wood system too. And you can also have an area with higher density for the transplants. And this could be an NFT system like this one, for example. For the previous system, transplants don't like deep water culture system. So we usually pair the deep water culture system with the ebb and flow system. So this is deep water culture, and this is ebb and flow system, because the plants don't like to germinate in a lot of water. So that's why we usually try to manage another system, an ebb and flow system, usually for deep water culture. For NFT, you can use NFT systems for the transplants. How we select the reservoir? Usually we want to consider at least half a gallon of water per plant. It will depend on the amount of plants that you have, and this will be the minimum. I mean, if you can put more water, is way better. The more water you have, the less fluctuations you will have in pH and electrical conductivity. So for the NFT system, we want to select pumps. And just to let you know, like quickly and easy how to select the pump, we usually have a slope, of course, so we can move the water with gravity. But in order to select the pump, we don't consider the length, because it's with a slope, but we consider the number of channels. So we usually want to target a flow of 4 to 7 gallons per hour. So that's the flow that we want in order that the plants can take up the nutrients and everything. And we multiply by the total channels that we have. So then after multiply, you will get the total minimum gallons per hour. So this will be like the power of the pump that you need. But usually this system, it has a reservoir. The reservoir sometimes is under the ground or is on the ground. So you need to consider also the height of the system. So we usually need to do this calculation. I mean, the target gallons per hour, and then multiply by the number of channels. And then use the final number. Let's say we got 400 by using the formula. And you need now to go and check the height of the system. I mean, where is the reservoir? Where are your plants? And then look for a pump that can help you to move the water with the power that you need, and also the height that you have. So this is an example. This is for a particular brand, and these are different pumps. And you can here look for the pump that will fit better for your system, based on the height and based on the power that you got from the formula. The other system that we can use is ebb and flow system. This is mostly used for microgreens or baby leaves or transplants. So everything that is small and germinating, because it's good for germination. In this system, we have a reservoir. We have different layers, like kind of trays. It's kind of similar to deep water culture system. In this case, we usually fill with trays inside, and the trays, they have holes on the bottom. So every time we're moving water, the water is going through the holes and reaching the substrate. Then the pump turns off, and we got the water back to the reservoir. So again, this is good for transplants and everything that is small, like baby leaves or microgreens. Usually you have a pump on the reservoir. For example, this is the grow rack from Hort Americas, and it has a pump that is 250 gallons per hour. So usually if you want to know how much time, for example, it will take to fill out each of the layers, you need, of course, to calculate the volume of water that you want in each of the layers. For example, in here, we have an example of 24 gallons that we require. And then we have the power of the pump, which is 250 gallons per hour. 1 hour is 50 minutes. So let's divide so we can get the rate of gallons per minute. And here we have 4.1. So that is the movement of water that we have per minute. And if we have 24 gallons, then it will take 5.8 minutes to fill the tray. So this is just very technical information on how to know or calculate when to turn on and turn off the pump. You can also use weight to fill out and take the measurement of time. But this is like technical information on how to make the calculations. It's an example of the grow racks from Hort Americas. These grow racks includes the lamps, everything. I mean, you just need to put your plants with the substrate and the seeds and nutrient solution. So the substrate that we use, usually we want to germinate in rock wool, or it could be oasis or any similar substrate. If you want to go organic, there are some options of cocoa peat that you can use for germination. And usually for leafy greens, we use this substrate only, and we move from the transplant area to the final growing area. This is an example of Grodan. This is one of the best brands of substrates for germination and in leafy greens. You can also use vermiculite to cover on top and to have better germination. You can see in here how the germination is with this substrate. And these are the organic options. We have a lot of growers now interested in organics. If you're working with microgreens, these are options of substrates. There is also rock wool or baked bamboo or biostrate, which are fibers that can be used to grow microgreens. You can also use peat moss or coconut coir. So, in order to finish, what can we grow inside of a vertical farm, or how can we start a business in this area? You need to look for the local markets to see what is the people demanding on the market, and look for something that can be selling a high price. We don't want to grow cheap stuff in a vertical farm. That's the truth for business. So we want to go, for example, to restaurants to see fine dining restaurants to see, for example, the requirement that they have for microgreens or baby leaves or lettuce. Usually you want to grow like fancy crops inside of a vertical farm to reach a higher price. So some options that are typically used by growers: lettuce, basil, culinary herbs, microgreens, baby leaves. We have now strawberry growers in vertical farms. There is research done on berries too. And of course, there is cannabis too. That's not vertical farm, but it's inside of plant factories. Good. And here I have just listed some common mistakes that we usually got from vertical farms based on experience and based on the experience with consulting with some growers. It's very important to learn about these systems before getting into it, and go from small to bigger, and take in consideration labor, take in consideration efficiency, and take in consideration all your capital and operational expenses. And also remember that plants never rest, so you need always to pay attention to your system with sensors or alarms or something. So about the presentation, just a summary. We have the vertical farming system that is involving lighting and different environmental variables, and we have this great business that can we also get involved with by looking for good customers and looking for good products that we can grow inside vertical farms in order to make a profitable project. And with that, I have finished. I wanted to put a lot of information together. I didn't want to, I was trying to pull out some information, but everything's so important. So I hope you enjoy the presentation. A lot of information here. So here's my email in case you have any questions. I will be here for the questions session. And here is my Instagram too, Professor Grow. And you can also go to the website of Hort Americas. We have free guides for you that you can download on this topic. And you can also check our YouTube channel where we have a lot of the videos about this topic too.
Thank you so much. Excellent presentation. Thank you so much. A lot of information.
Yeah, so I'm sorry, that was a lot of information. I was trying to pull out some information. I will just go quickly.
We are happy. We want a lot of information. So I'm going to ask if there is a people with a couple of questions, and then the rest of the question they can be for later during lunchtime. So let's ask. Yeah, we're gonna use. So is there anybody with question? Yes, there is one question from Erico Matos.
Hi, Karla. Wow. Can I try again? All right.
I'm mute, okay. Okay, mute. 1 second.
Try again.
I guess they need to come up for a question. They need to come up here to.
Yeah.
Yeah.
Right.
Yes. Can you come up to?
Try again. Just go there.
Yeah. Okay. Can you hear us?
Yeah.
No, the
We cannot
mute
hear.
now.
Yeah.
Unmute everything, Victor.
Can you hear us?
Yes.
All right.
Hi, Karla. Thanks for the presentation. This is Erico Matos. I had a question about the ventilation system that you showed from the professor at University of Florida. The little pipes to the pressure air. I've never seen those before. Would you be able to tell us a little bit more about those? That was super interesting.
Sure. There are different ways to put ventilation inside of a plant factory. We usually can use like computer fans or to have fans in each of the layers. This is a system that was designed at the University of Arizona. Now Jean graduated and is now a professor at the University of Florida. But this is a system that blows air on top of the plant, which is better actually for lettuce, for example, to avoid deep burn. So it's not like the typical ventilation system that you see, but it's very interesting to go and learn more about these strategies on ventilation because this is to improve uniformity inside of the systems. Most growers, they do ventilation like just normal fans, like, like the desktop fans or computer fans in each of the layers. But this kind of ventilation will allow you to have ventilation from the top to the bottom of the plant, which is better in terms of preventing, the boundary layer resistance.
Can you ask if it's commercially available?
He's asking if it's commercially available.
The system, no. I mean, you can make the system. If you see the article, you will get like all the instructions to make the system, but it's not something that is sold by a company right now.
Okay, thank you.
One more question.
One more question.
Hi, I'm Eva Chicado from the CCPP. Hi, very nice talk. Thank you. I have a question. Is there a distance that you recommend from the lights to the top of the plants at all times?
Yeah, that's a good question. Depending on the crop, of course, but we want to have at least like 1 feet usually. Not because the light intensity, but because of the ventilation. It could be less. I mean, you can have the plants and just like 10 centimeters and then the lights, but it will be more challenging to promote ventilation and avoid deep burn, which is very typical, for example, inside of a vertical farm. So we always want to have a distance, not because of the lights, but because of the ventilation. Usually it's about 1 feet here. Actually, where is it? I think it's in here. And here is an example for, this is for lettuce. And this is the distance. So it's like 0.63 meters.
Right.
63 centimeters.
63 centimeters. Okay.
Okay.
And between plants, does it depend? You showed, I think you have, and did you have the nutrient film with the lettuce? Did I?
For the plants
at the top with the ebb and flow, you had a system where they were kind of quite spaced out. Is the spacing the same throughout the growth stages, or does it depend on the crop? I understand you have a different phase of germination, but what about the growth of the plant? Do you have a different spacing depending on the growth stage?
Usually we have the same distance. We have, you know, the germination trays at the transplant area, and then in the final growing area we have the same distance all the time. It's like 24 heads of lettuce per square meter. That's typically the density that we recommend. But I always recommend to the growers to ask to the person that is selling the seed for the specific cultivar, because if you can put more, it's always better. So that is like a general number. There are some technologies from some companies that they have developed systems that can move the plants with the development, which is way better. But usually the typical that we see is a floating wrap that is already with the holes, and it's usually about 24 heads of lettuce per square meter. And for basil, it's 45 plants per square meter.
So what's the minimum distance between one plant and the other? You always
that
have
would be like 10, 15 centimeters.
Thank you.
Thank you. Okay, other question? Okay, I have one question about photons. I want to ask, a green photons or a red photons or a blue photon? If you have a light, if you have an LED light that it's only red or blue, or one that it's only green or blue, is it gonna, are you going to read the same PPFD if you set it up at the same intensity, or is it gonna be different?
That's a great question. It will be different. And at the base, the best way to explain this is if you measure, for example, in luxes, which is another unit, you can get like white LEDs and red and blue LEDs, and you can get the same luxes. And if you make the conversion to PPF, you will notice that the PPF is higher under the red and blue light, because that promotes more photosynthesis. That is the importance on why to use the correct unit.
Okay, thank you so much. I wanted them to know. All right, I think we'll thank you so much, and we're gonna pass to the next speaker. So yeah, we're gonna talk to you a little bit later during lunchtime. All right?
Perfect. Thank you.
Thank you, Karla.
Thanks, you're welcome. I hope you enjoyed the presentation.
Thank
Bye.
you.